88.45. Microsoft published that number on May 12th against a cybersecurity benchmark most of you have never heard of. Against a model Anthropic built specifically to find exploitable vulnerabilities. MDash scored 88.45% on CyberGym. Anthropic's Mythos scored 83.1. GPT 5.5 scored 81.8. A 5-point gap on a benchmark measuring 507 real tasks. That gap changes what you build next. That gap is not a model quality story. It is an architecture story. Microsoft did not build a smarter transformer. They built a system of 100 specialized agents and let them argue with each other. And then they proved it was not just a benchmark. MDash found 16 real vulnerabilities in the Windows networking and authentication stack. All 16 patched in the same Patch Tuesday release. Anthropic built Mythos in 2025 for defensive cybersecurity. Single model, agent framework wrapper, designed to run inside your software development lifecycle and surface exploitable bugs before attackers do. Microsoft adopted it. If your code runs through Microsoft's security development lifecycle, Mythos is already scanning it, which makes MDash an interesting decision. Microsoft built a competitor to their own adopted tool. Dario Amodei has been explicit. If AI can find vulnerabilities at scale, offensive actors will use it. Mythos was Anthropic's attempt to give defenders the same capability first. That framing matters. Microsoft is still running Mythos inside their security development lifecycle. MDash is separate. They are not replacing one with the other. They are running both. That is a sign they trust neither system fully. MDash is not a model. If you are evaluating AI security tools, that distinction matters. It is an orchestration system running more than 100 specialized agents across frontier and distilled models. Each agent has one job. 4 agent types. This is the structure you need to understand. Auditor agents find candidates. Debater agents challenge every finding. Prover agents verify exploitability end-to-end. Validators remove false positives before anything reaches you. Auditor agents run across frontier and distilled models simultaneously. Your attack surface gets scanned by agents specialized to different vulnerability classes: memory corruption, injection flaws, authentication bypasses. Every finding goes to a debater agent. Its job is adversarial. It tries to disprove the finding. If a candidate vulnerability cannot survive internal debate, it never reaches your prover. The prover agent is the expensive step. It attempts to construct a working proof-of-concept exploit, end-to-end. This is what separates a theoretical bug from something your security team actually patches. The model-agnostic design means you can swap any individual model without rebuilding the pipeline. Microsoft runs models from multiple providers simultaneously. When a better model ships, you slot it in. CyberGym was published by UC Berkeley in 2024. 1. 507 real-world vulnerability tasks drawn from 188 open-source projects. The benchmark code is public. You can run it yourself. 1. 507 tasks, each one based on a real vulnerability from a real project. The system has to find the bug, understand it, and prove it is exploitable. You do not get credit for finding. You get credit for proving. MDash at 88.45, Mythos at 83.1, GPT 5.5 at 81.8. In a benchmark measuring whether you can prove a bug is exploitable, a 5-point margin is not trivial. Here is the caveat you should hold. These scores are self-reported. Microsoft submitted their own number. No independent lab verified it. The benchmark code is public, but nobody else ran the test. The benchmark score is a claim. The 16 vulnerabilities are not. Microsoft shipped patches for all 16 on May 12, 2026. Patch identifiers. Patch Tuesday. You can look them up. Independently verifiable. MDash found 16 vulnerabilities in the Windows networking and authentication stack. 4 were critical remote code execution flaws. All 16 made it into Patch Tuesday. That is not a demo. That is production output. 4 critical remote code execution vulnerabilities. 2 in the Windows kernel networking stack. 1 in the IKE v2 service. These are the bugs ransomware groups pay for. If you are on Windows, these were in your machine. Charlie Miller, one of the first researchers to demonstrate a remote iPhone kernel exploit, spent weeks on that single vulnerability. MDash is compressing that cycle. What took Charlie Miller weeks, you now potentially automate in hours. Patch records are public. Patch Tuesday releases are auditable. You can verify the 16 vulnerabilities exist independently of anything Microsoft says about MDash. That evidence is structurally different from a self-reported score. A single model asks you to trust it is good at finding bugs, evaluating them, and proving they work. Those are 3 distinct tasks with different error modes. Specialization lets you compress each one independently. So why does this architecture actually win? The debate layer. Every finding gets challenged before it advances. Your false positive rate drops because findings have to survive an internal adversary before your team sees them. MDash runs models from multiple providers simultaneously. Your threat surface gets coverage from agents built on different architectures with different training distributions. Gaps in one model get caught by another. When GPT-6 ships, Microsoft slots it into the prover role without rebuilding anything. When a faster distilled model drops, your auditor agents get cheaper. The pipeline is the product. The models are components. Gene Spafford, Purdue's security professor, once wrote that the only truly secure system is one cast in concrete and sealed in a lead room. Everything else is a trade-off. MDash is a trade-off. 88.45 is a self-reported number on a self-administered benchmark. Companies optimize for the test, not for your threat model. A 5-point lead on CyberGym does not mean MDash finds 5% more vulnerabilities in your production code. The 16 CVEs are what you weight more. Independently verifiable, real production impact. That evidence is structurally different from a leaderboard position. A good security team distinguishes between the two. MDash is not available to you yet. Private preview, select enterprise customers. But the architecture pattern Microsoft demonstrated is reproducible without Microsoft's budget or model access. If you are running a security engineering team, the pattern is automated scan, automated challenge, automated proof attempt, human triage on confirmed findings only. Most of your pipeline should have no human in the loop. You do not need 100 proprietary agents. You need a workflow where every finding gets challenged before it reaches your team. One scan agent, one challenge step, one proof attempt. Start there. The larger signal is that Microsoft ran competing providers, models together, and got a better result than any single provider. Your architecture does not have to pick a winner. It has to pick a good pipeline. The model war in security AI is not going to be won by the single smartest model. It will be won by the team that engineers the best pipeline. Microsoft just demonstrated that. Anthropic is watching. If this saved you time, subscribe. We cover AI architecture decisions before they hit your architecture reviews. See you in the next one.